Welcome to the R-Wave Universal Intelligence Lab. Today, we are opening the file for task XN26VJPX. Okay, let's just jump right in with a question that could, well, change everything. We tend to think of creativity as this magical, unpredictable spark, right? But what if it's not? What if you could actually train your brain to be innovative whenever you needed it? That's the incredible idea we're going to unpack today. All right, so here's the challenge, the problem we're really up against. It's something called the creativity gap. You see, for centuries, we've gotten incredibly good at learning structured stuff. Think about it, math, history, you name it. But in all that, we've developed this huge blind spot. We are great at teaching what we already know, but we've really struggled to encourage that spontaneous, out-of-the-blue kind of thinking. You know, the thinking that actually solves the world's biggest, newest problems.
And this really lays it all out, doesn't it? On one side, you've got structured learning. We have optimized this for centuries. It's how we learn languages, how we build bridges. It's absolutely essential for solving problems we've seen before. But then there's the other side, creative ideation. That's the spark we need for challenges we have never seen before. And that incredibly powerful part of our mind, it's just sitting there, largely untapped. That's the gap we're trying to close.
So the big question is, how do we bridge that gap? Well, the solution is a pretty radical new way of looking at things. Imagine your brain is a complex orchestra. You've got all these different neural regions. They're like the strings, the brass, the percussion. Sometimes they all play together in perfect harmony, and you get this beautiful music, right? An amazing idea. But other times it's just noise. So what's the goal of this new tech? Simple, to become the brain's conductor. To really get this, we have to look at those moments of perfect harmony. In the research, they're called Optimal Cognitive Coherence Signatures, or OCCS for short. Just think of them as the exact measurable brainwave patterns that fire up during one of those aha or eureka moments. You know, that instant when an idea just clicks. It's literally the brain's orchestra hitting a perfect, beautiful chord.
And this is the whole point. The goal here isn't to just sit around and wait for those moments of harmony to happen by accident. No way. It's about learning how to compose the music ourselves, to intentionally tune our brain's activity and hit that state of peak creativity whenever we want.
Okay, so how is this even possible? This is where the conductor, the technology, steps in. It's a framework with a bit of a mouthful of a name, Quantum-Coherence-Optimized Inducement Protocols, or QCOIP. Basically, it uses some really advanced principles from quantum machine learning to gently, sort of nudge, the brain's neural networks into those perfect patterns for creative thinking. It's the conductor's baton signaling exactly which symphony the orchestra should play. So let's break that down a bit. How does this QCOIP thing actually work? Well, it uses that advanced quantum machine learning to first spot and then gently adjust these specific brainwave patterns. The whole point is to boost what's called divergent thinking, which is just our ability to explore tons of different solutions to a problem. It also helps our brain form new connections more easily. And what's really fascinating is that it could actually make being creative feel, well, less like pulling teeth and more like just flowing. Of course, an idea this big, this revolutionary, you can't just take it on faith. It needs some serious, rigorous proof. So let's dive into how this theory is actually being put to the test in a really carefully designed scientific trial. And the protocol for this is, as you'd expect, incredibly meticulous. First up, they measure everyone's creative baseline to see where they're starting from. Then, one group gets the actual QCOIP session. After that, both groups are given these really complex, open-ended problems to solve. And the whole time, scientists are not only assessing their ideas, but also watching their brains with things like EEG and fMRI to see exactly what's changing under the hood.
Now, this part really speaks to the scientific integrity here. We're talking about a double-blind controlled trial. That means there's a control group that gets a placebo or a sham intervention. And this is so important because it makes sure that any effects we see are genuinely from the technology and not just, the power of suggestion. Both groups are being monitored with the exact same advanced tools, so it's a true apples-to-apples comparison.
Okay, so with an experiment this solid, what are the projections? What are we hoping to see? These next few metrics really give us a glimpse into a potential future. A future where our own creativity isn't just a happy accident, but something we can systematically improve.
All right, let's get into the numbers. First off, a 65% predicted probability of success. Now, that might not sound like 100%, but let me tell you, for a leap this ambitious, for something that's basically creating a whole new scientific paradigm,
65% is an incredibly strong signal. It tells us the underlying science is really, really solid.
Next up, and this one is absolutely crucial, safety alignment is at 98%. This is and always has to be the #1 priority. That number reflects a massive amount of work in preclinical modeling to make sure that participant well-being is protected above everything else.
And finally, we get to the whole point of this, right? A 95% potential novelty score. Now, what does that mean? It means the prediction isn't that people will just have more ideas, but that the ideas themselves will be fundamentally new. We're talking about a measure of true, genuine innovation here.
So when you put all that together, the picture becomes crystal clear. You've got an extremely high safety profile, an incredible potential for generating truly novel ideas, and a really strong probability of success. It's that combination, that trifecta, that makes this research so unbelievably compelling.
And in the end, it all comes back to this one central idea. This was never just about cool technology for the sake of cool technology. The real goal here, as it says right there in the scientific record, is to enhance our own human capabilities, to finally unlock the full, incredible potential of the human mind. This is R-Wave Universal Intelligence Lab, signing off on Task XN26VJPX, dedicated to humanity.